Welcome to Tech Blueprint, a window that lets you know the latest technology news in the world. In 2024, the global photolithography material market grew against the trend to $4.74 billion, and the demand for EUV photoresist soared by 30%, directly driving the entire market to $5.06 billion in 2025. TSMC's 3nm chip contains 19 layers of EUV photoresist, and Samsung's 2nm factory burns golden consumables worth millions of dollars every day. The electricity bill of an EUV lithography machine is enough for a small town for a year, but Canon's newly launched Nanoimprint equipment consumes only 1/10 of its energy. In the photolithography material market's $4.74 billion in revenue in 2024, EUV photoresist contributed $520 million, 20% more than in 2023. By 2025, this number will increase by another 30%. In TSMC's 3nm production line, each wafer undergoes 19 EUV lithography, nearly 4 times more than the 7nm era. Samsung's 2nm factory is even more exaggerated, and the number of EUV lithography layers is expected to exceed 25. Japan's JSR company monopolizes 45% of the global EUV photoresist market. There are more than 50 nano-level additive formulas hidden in their laboratory. It takes 10 years to develop a new formula. Lam Research's dry photoresist has just passed the certification of the Belgian Microelectronics Research Center and can carve 28 billion transistors on a chip the size of a fingernail. This technology uses gas instead of liquid to reduce the photoresist defect rate from 200 parts per million to 80 parts per million. Canon's Nanoimprint equipment occupies only 1/3 of the EUV lithography machine, and the power consumption is reduced by 90%, but the precision of the 14nm circuits carved out is not inferior to EUV. The U.S. CHIPS Act has invested $52 billion, requiring local chip factories to use more than 30% of US-made photoresists. Japan's JSR urgently built a new factory in South Korea to increase EUV photoresist production capacity by 50%. China's Nanjing Optoelectronics RF photoresist has just passed SMIC's verification and will sell 400 tons in 2023, but the price per ton is 15% lower than that of Japanese products. On SMIC's production line, the yield rate of domestic KRF photoresist has reached 98%, but EUV photoresist is still in the laboratory stage. An engineer from a domestic photoresist company revealed that the EUV samples they made can barely be used at the 28nm node, but at 14nm, the pattern loss rate is 20% higher than that of Japanese products. TSMC's CoWoS packaging technology used in NVIDIA's H100 GPU requires photoresist to achieve 99.999% pattern integrity at a 2-micron spacing. This is equivalent to drawing a full circuit on A4 paper with a brush, and not a single stroke can be wrong. In order to meet the standard, photoresist companies upgraded their testing equipment to 0.1 nanometer accuracy, which is 100 times smaller than the new coronavirus. IBM used AI algorithms to cut 70% of the time for photoresist research and development. In the past, it took 5,000 attempts to adjust a formula, but now the machine learning model can lock the best combination after running for 3 days. The EUV lithography machine of ASML in the Netherlands consumes 3,000 liters of ultra-pure water every day, but Canon's nano-imprinting equipment does not even need a water cooling system. In 2023, TSMC purchased 18 high-NA EUV lithography machines, and the price of each machine rose to $380 million, enough to buy 12 Airbus A320 aircraft. According to the financial report of Japan's Shin-Etsu Chemical, the gross profit margin of photoresist will reach 58% in 2023, which is more profitable than selling iPhone chips. However, in the financial reports of Chinese companies, the photoresist business is generally in the red. Shanghai Xinyang's photoresist revenue in 2023 was $230 million, but R&D investment burned $310 million. The mask cost of TSMC's 3 nanometers chip exceeded $20 million, of which photoresist accounted for 35%. If Japanese EUV photoresist is used, the cost of each wafer will increase by $200, but if a substitute is used, a 1% drop in yield will result in an additional loss of $500. In the global photoresist patent library, Japanese companies account for 73% of EUV-related patents. China's EUV patent applications in 2023 have soared by 80%, but 90% are concentrated in the packaging field. Despite significant progress, China's semiconductor industry still faces multiple challenges. In the field of key equipment such as EUV lithography machines, the situation of more than 90% dependence on imports has not changed fundamentally. The 0.55 numerical aperture technology of ASML's latest high-NA EUV lithography machine pushes the process to below 2 nanometers, which is still an area where domestic equipment urgently needs to break through. The bottleneck on the material side is also prominent. The localization rate of 12-inch silicon wafers is only 10%, and the category coverage rate of photoresists is less than 40%. These invisible shortcomings restrict the overall upgrading of the industry. But there is a turning point in the crisis. The US technology blockade unexpectedly gave birth to an innovative ecology with Chinese characteristics. Huawei's Taishan plan has gathered more than 2,000 supply chain companies to build a complete replacement system from EDA tools to packaging and testing. The chiplet technology developed by the Institute of Microelectronics of the Chinese Academy of Sciences modularizes chips of different process nodes through heterogeneous integration, and achieves equivalent 5 nanometer performance on a 14 nanometer platform. This system-level innovation is rewriting the rules of the game. In 2025, China's patents in the field of RISC-V architecture chips accounted for 38% of the world, laying the foundation for building an independent technology ecosystem. From microns to nanometers, from two-dimensional to three-dimensional, the evolution of China's semiconductor industry confirms a truth: technological blockades cannot lock innovative thinking, and process gaps cannot stop system breakthroughs.